Hey there, and welcome. We're going to jump right in and demystify one of the biggest concepts in AI right now, Retrieval-Augmented Generation, or RAG. My goal here is really simple, to make sure you can walk into any technical interview and explain this concept with total confidence. So let's get you prepped.
All right, picture this. You're in the interview, it's going great, and then the hiring manager leans in and asks, "So, can you explain RAG to me?" For a lot of AI roles today, that is the make or break question. My job here is to make sure you have a clear, confident, and really impressive answer locked and loaded.
So, here's how we're going to tackle this. We're going to break it down into 5 key parts. We'll start with the absolute basics, the core components. Then we'll get into the foundational indexing process, map out the entire pipeline from start to finish, and then we'll really dig into the specific jobs of retrieval and generation. By the end of this, you'll see the whole picture, clear as day.
Okay, first things first, let's get right to the heart of it. At its most basic level, what are the 2 main engines that actually make a RAG system work? And you'll see, it's a surprisingly simple idea. A RAG system really has 2 distinct parts that work as a team. First up, you've got retrieval. Think of this as your expert search engine. Its only job is to go through mountains of data and find the most relevant little nuggets of information for whatever question you've asked. And then you've got generation. This is your large language model, the writer. Its job is to take the info that retrieval just found and spin it into a clear, human-sounding answer. So one finds, the other explains. Simple as that.
And here's the perfect analogy that will make this concept stick in your head. Just think of a RAG system as a really smart student taking an open book exam. When they get a tough question, they don't just guess based on what they remember. No. First, they search the textbook for the exact right information. That's the retrieval part. Then, they use what they found to write out a thoughtful answer, and that's the generation part. It's really that intuitive.
Okay, so if the system is like a student with an open book, how does it organize that book so it can find anything in a split second? Well, that brings us to this absolutely crucial preparation stage, indexing. And you got to understand, without indexing, the system would have to read every single document, word for word, every time you asked a question. Can you imagine? It would be unbelievably slow. Indexing is the process of creating a smart, searchable map of all your knowledge before anyone even asks a question. It's what makes the whole thing fast, relevant, and powerful enough to handle millions of documents. So how does this indexing actually work? Well, it usually breaks down into 5 key steps. You start by collecting all your data, your PDFs, docs, web pages, the whole shebang. Second, you clean it up, get rid of weird formatting. Third, and this part is super important, you break the text down into smaller, manageable pieces, or chunks. The 4th step is to create what's called an embedding for each chunk. We'll talk about that in a sec. And finally, you store all of that in a special kind of database called a vector index, which makes it ready for a super fast search.
So what on earth is an embedding? This is a really core concept. Think of it like a numerical fingerprint for a piece of text. It's a long list of numbers that captures the semantic meaning, the vibe, the concept of that text. This is the magic that lets the system search by meaning, not just by keywords. It means that chunks of text with similar ideas will have similar numerical fingerprints, and they'll be stored close to each other in the database.
All right, we've got the prep work down. So now let's zoom out and look at the entire picture. How do all these pieces, the indexing and the real-time stuff, actually come together? Let's walk through the entire workflow from the moment a user asks a question to the final answer they get back.
You can really think of the pipeline in 2 big parts. The first part is that offline preparation phase we just covered. Sometimes it's called indexing, sometimes ingestion. This is where we do all the heavy lifting up front, collecting, cleaning, chunking, embedding, and storing all our knowledge. This is all done ahead of time to set the stage for what comes next.
The second part is the real-time querying phase, and this happens every single time a user asks a question. First, the user's question itself gets turned into an embedding, just like the document chunks did. Then the system uses that question embedding to find and retrieve the most relevant chunks from the database. Next, it bundles the original question and those retrieved chunks together into a new, super-informed prompt. And finally, the LLM uses all of that rich context to generate the final accurate answer.
Okay, get ready to memorize this. This is your money line for the interview. If they ask you to describe the RAG workflow, you can confidently say, a RAG pipeline has 2 main phases, an offline indexing phase, which includes ingestion, chunking, and embedding,
and an online query phase, which involves retrieval, prompt construction, and final answer generation. It's concise, it's accurate, and it shows you get the whole process.
We keep talking about retrieval, but let's really zoom in on it for a second. What is its specific job in this whole system? And why is it so incredibly important?
Another analogy really helps make the division of labor crystal clear. Think of the retrieval component as a hyper-efficient librarian. Their job isn't to explain the content to you. Their job is to find the exact right book and the exact right page that has the answer you need. The generation component, then, is like the writer who takes that page from the librarian, reads it, and then explains it to you in a way that's easy to understand.
This basically makes the retrieval component the ultimate gatekeeper. It has one of the most critical jobs, because it literally decides what information the powerful language model even gets to see. Think about it. If retrieval pulls up junk, the LLM has no chance of giving a good answer. It doesn't matter how brilliant your language model is, it can only work with what it's given. So, strong retrieval means accurate answers. Weak retrieval, the whole system falls apart.
So here's another polished takeaway for you. You can say this: the retrieval component performs a semantic search to find the most relevant context and then feeds it to the LLM. This is what grounds the model's response in facts, allowing it to generate an accurate answer instead of just guessing from its internal memory.
All right, last section. Let's put it all together. We have these two powerful pieces, retrieval and generation. What is the ultimate goal of mashing them together? Why does this RAG architecture even exist in the first place?
The whole reason we do this, the fundamental goal, is to make LLM responses way more accurate, reliable, and just plain trustworthy. We're essentially shifting from a model that just predicts what word sounds right next to a system that answers questions using verified, factual information that we gave it. It's a huge shift from creative writing to evidence-based answers. And this side-by-side really drives the point home. On one hand, you've got a standard LLM. It's just answering from its massive but static pre-trained memory. This means it can hallucinate, just make stuff up, and it has no idea about your private company data or anything that happened after its training cutoff date. But on the other hand, you've got RAG. It answers directly from facts it pulls in real time. This slashes hallucinations and gives it secure access to any data you want it to have, no matter how new or specific.
And here it is, our final interview-ready gem. The whole point of integrating retrieval with generation is to ground the LLM's outputs in external, verifiable knowledge. This is absolutely key to reducing hallucinations, ensuring the information is up to date, and enabling truly context-aware responses.
Look, if you forget everything else, just remember this one simple phrase. It's the cleanest, most powerful way to think about RAG. Retrieval's job, find the truth in your data. Generation's job, explain that truth clearly. Together, they create a system you can actually rely on.
So, there we have it. We've covered the components, the process, the roles, and the all-important why. You've got the analogies, you've got the technical steps, and you've got the polished summaries ready for your interview. The only question left is, are you ready to go in there and knock that question out of the park? I think you are.